Have you ever wondered what would happen if you could travel at the speed of light? Would time slow down for you? Or would you age slower than everyone else on Earth? The answer will blow your mind. Well, today, we're going to explore exactly that. Welcome back to the channel. We're diving into one of the most mind-bending ideas in all of science, Einstein's theory of relativity. Now, I know it sounds super complex, but don't worry. By the end of this video, you'll understand how time slows down, how gravity can bend space, and how this theory affects even the GPS on your phone. Get ready to have your mind blown. Let's go. Chapter 1. Time dilation, when time slows down. Let's start with something that sounds like science fiction but is actually real, time dilation. Imagine you're an astronaut flying through space in a super-fast spaceship, moving close to the speed of light. Inside the spaceship, everything feels normal to you. But here's the twist: if someone on Earth is watching you, they'll notice something really weird. Time is moving slower for you compared to them. What does that mean exactly? Let me break it down. Suppose you spend 1 year traveling at super high speeds in space. When you return to Earth, you might feel like only 1 year has passed for you, but for the people on Earth, 20 years could have passed. While you were zooming through space, they aged 20 years, but you only aged 1 year. Isn't that mind-blowing? This is time dilation in action. So, the faster you move, especially at speeds close to the speed of light, the slower time passes for you. It's like having a slow motion button for your life, but only for you while everyone else moves at normal speed. Chapter 2. Gravity, how massive objects bend space and time. Next up, let's talk about gravity. We all know gravity is the force that keeps us on the ground, right? But Einstein had a completely new idea about gravity. Massive objects like stars and planets bend space and time itself. To help you picture this, imagine you have a stretched out sheet, and you place a heavy ball in the middle. The sheet bends, creating a dip in the fabric. Now, if you roll a smaller ball on that sheet, it will roll toward the heavy ball. That's exactly how gravity works in Einstein's view. Massive objects like the sun bend space and time around them, and that's what causes planets to orbit. So, instead of thinking of gravity as just a force pulling things down, imagine spacetime itself getting stretched and curved by big objects like the sun. Chapter 3. Gravity and time, a time warp. Now here's something even more mind-blowing. Gravity doesn't just bend space, it bends time too. The stronger the gravity, the slower time moves. Let me give you an example. Time actually moves just a tiny bit slower on Earth compared to a satellite up in space. This is because Earth has stronger gravity, so time runs slower here than it does in space, where gravity is weaker. You can think of it like a race between two clocks, one on Earth and one on a satellite in space. The Earth clock would be ticking a little bit slower because of the stronger gravity. So, GPS satellites have to adjust their clocks all the time to keep everything accurate because they're affected by this difference in time. Isn't that wild? Without these adjustments, your GPS would start giving you wrong directions. Chapter 4. Special relativity versus general relativity. Alright, now that we know about time and gravity, let's talk about how Einstein's theory of relativity fits all this together. The theory has two main parts: special relativity and general relativity. Special relativity is all about how time and space behave when things are moving super fast, close to the speed of light. It explains things like how time slows down when you travel really fast. General relativity, on the other hand, talks about how big, heavy objects like planets and stars bend space and time, creating gravity. Special relativity is about objects in motion and how they experience time differently. General relativity is about massive objects and how they shape space and time around them, causing gravity. They work together to explain the strange and amazing ways the universe works. Chapter 5. Relativity in Action, GPS and more. Now, I know all this might sound a little confusing, but here's the cool part: Einstein's theory is actually working around us all the time. For example, every time you use your GPS on your phone, you're experiencing the effects of relativity. GPS satellites are up in space, and because of the difference in gravity between Earth and space, time moves a little bit differently for them. The satellites have to adjust their clocks to account for this difference in time. Without these adjustments, the GPS would get your location completely wrong. So next time you check your map on your phone, remember, relativity is making sure you don't get lost. Conclusion. So, there you have it. The next time you're looking up at the stars, or using your GPS to get somewhere, you're seeing the power of Einstein's theory of relativity in action. It's a mind-blowing concept that helps us understand the universe in a whole new way, and it's even shaping the technology we use every day. Thanks for watching. If you enjoyed this video, make sure to hit that subscribe button and give it a like. And as always, keep exploring the wonders of the universe. Until next time, stay curious.